Good morning, mathematicians. We are looking at our Section A checkpoint for Unit 1. We're going to take a look at these 3 questions so that you can really assess your own mastery of our Section 1 content. So number 1 starts us off with which figure has a greater volume. We want to remember that volume has to do with how much space a figure takes up. So that is what we're looking for. Which one takes up more space? So thinking about this, let's go ahead and start with A, which really what we have to do for A is simply count the cubes, right? So when I take a look, I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can take a look at A and see that it has exactly 10 cubes. Now, when I take a look at B, I can count the cubes, or I can remember that this is a 3 by 3 array, which 3 by 3 would tell me that you would use 9 cubes, and certainly you could also use the strategy of simply counting the cubes, in which case we would look and see we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way you problem solve, you're finding that figure B does have 9 cubes. So that tells us exactly what we need to know to say which one has the greater volume. Because remember, we weren't looking for what is the volume of A and B. We were looking for which one has a greater volume. So let's write out our answer down below. We're going to say that figure A is 10 cubes. And figure B is only 9. Then let's make sure that we make it very clear that because of that, we know that figure A is the greater volume. And let's even go ahead and say that the reason is because, so figure A is the greater volume because it takes up more space. Okay, so that is the problem solving, but also a great way to formulate your answer specifically to number 1. Now let's go ahead and let's take a look at number 2. Number 2 says to find the volume of each prism, and we are to explain or show our reasoning. So as you take a peek, you'll see that we do have figure A, and we also have a figure B. We're going to be talking about both of those in our answer for number 2. So first of all, when I take a look at number 2, I can see, first of all, that it has 2 layers, right? So that is one really important thing to think about, is that it has 2 layers. Now it has 2 layers of how many cubes? We might want to think about that. Well, I can take a look. I could even count the top layer. I could see that that top layer has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it has 2 layers of 15 cubes. This means it has a volume of 20 cubes, or excuse me, 30 cubes. It has a volume of 30 cubes. Because we would certainly have 15 on the bottom layer, 15 on the top layer, and that gives us a total of exactly 30 cubes. So I have said what my answer is, but I've also explained the reasoning, because certainly those layers and the layer structure can be so important to finding volume of a shape. All right, let's go on down to number 2, B. Number 2B, remember that volume is, when we're looking at a prism like this, we're going to fill the prism with cubes, as many cubes as it can have. So certainly these two cubes that stand on top are really just to show us what the actual height is of the shape, or how many of those layers it certainly could have. So let's take a look first at this base layer. Remember that where I put the arrow, that is the base layer. Now the base layer is 1, 2, 3, 4, 5. It has a length of 5, and 1, 2, 3, 4, it has a width of 4. So if I have 5 by 4, if I have a 5 by 4 array of cubes, then I know that this bottom layer would have 20 cubes, right, in the bottom layer. But what's important to remember is I could also have 20 cubes for this layer. Where I see 1 cube there in the middle layer, I could go ahead and actually have 20 cubes for that middle layer. And remember, we could also have 20 cubes for this top layer. So if I have 3 layers of 20 cubes, I'm going to have 60 cubes. So the overall answer for B is this idea of 60 cubes. Now we do need to go ahead and explain this. So we could point out that the base layer, where we started on the bottom, the base layer has 20 cubes. And there are 3 layers to the full prism, right? Okay. Now, it's not all filled in, and that's okay, but I can count the cubes to get the dimensions, and I know that that particular prism can hold 60 cubes. So that is it for number 2B. We simply have one more question for this section A checkpoint, and this number 3 says to explain or show how the expression 4 times 6 represents the volume of the rectangular prism in cubes. Where do I see 4 times 6? Well, first of all, let's stop and ask, how many layers does this prism have? Well, this prism has the ability to have 4 layers because it has a height of 4. Now, how many cubes are in each individual layer? In the 4 layers, how many cubes would be in each layer? Well, if I take a look, for example, at this top layer has how many cubes? It has 6 cubes. 1, 2, 3, 4, 5, 6. So how do I see 4 times 6? What's really important to remember is that the layer of the cube, the layer structure of the cube is that I can have 4 layers of 6 cubes, right? So let's go ahead and let's write that out as our answer, because really this is wanting us not to tell how many cubes the volume is. It's really just wanting us to relate it back to that particular expression, okay? So we could write the individual layer, the individual layers have 6 cubes. How about that? There are 4 of those layers. Therefore, the volume is 4 times 6. Okay, we have related it to what the 4 means, what the 6 means, and we've given some clear rationale for the idea of 4 times 6 representing the overall volume. That completes this Section A checkpoint for Unit 1.